When you comb your hair, you may have noticed with dry weather that you hear some cracking noise. Cracking noise means sparks. And you will learn all about sparks in this course, though not today. But you can hear it if you're very quiet. And as you do that, you charge the comb. I can hear the cracking. Interesting. So the comb is now charged, probably, so am I. And there it comes. You see? It's not as good as the glass, but same idea. If you take your shirt off and you make it dark in your dormitory and you stand in front of a mirror, an amazing experience. And I'd be happy to do it for you because, but I told you I already wear cotton and it doesn't work with cotton so well. You really have to do it with a nylon shirt. And when you take that nylon shirt off, not only do you hear the cracking, but you actually see the glow of these teeny, really little sparks. You actually are like a light bulb. It is an experiment that you cannot miss. And I would suggest you try that this weekend. And do it with a friend, that's even more fun. We all perhaps remember when you just walk around, do your normal things during the day. There are rugs in rooms and you want to leave the room and you touch the doorknob and you get a shock. It's a spark that flies over. It's the electricity. Even when you touch a person, you sometimes feel this shock. When you cook and you take saran wrap of these rolls, the damn stuff just doesn't want to come off because as you roll it off, there is friction and it gets charged and it often gets crumbled up. And it's very bad, very difficult to handle it. You've all experienced that. Also, cellophane around boxes with chocolate, the same thing happens. As you take it off, you charge it, whether you like it or not. I now want to do an experiment, and I need a volunteer. I need a student who actually is wearing, preferably not all cotton, but I think, Simon, you have a beautiful, wonderful nylon parka. So if you are willing to sacrifice a little bit for the sake of science and come over here and sit down here. Just relax. Make sure that your feet are off the ground. Okay. So what I'm going to do now, Simon, I'm going to beat you with a cat fur. And as I beat you with cat fur, you will get charged. And since I don't want you to be the only person who suffers under this experiment, I will also stand on an insulated stool. So if you become, for instance, positively charged, I don't know whether it's positive or negative, I would get the other amount of charge. So we share in the charge. And as I beat you, you will charge up more and more, and I will charge up more and more. And then we will have to convince the class that we are both charged. And we will do that in a way that will be hopefully rather convincing. Let me just start beating you a little bit to make you feel at home. We know each other, right? Okay. Now, of course, as I mentioned to you, these experiments work well when it is dry. And so, if you are too wet, it won't work. But let's see, if you sweat a little bit too much, then it doesn't work too well. So, you ready? I have here in my hand a neon flash tube. And although we don't know yet what voltage is, because we will learn about that in this course, to get a good flash out of this you need about a few thousand volts. And so we will see, and we'll make it dark shortly, and I will hold the flashlight in one hand, the neon discharge tube, and then Simon will touch it on the other side. And if we succeeded, then you may see some light. So Simon, look at me first, don't touch it yet, because we're going to make it all the way dark. You know where it is? It's there. Okay, make it dark, Marcos. Touch it. Touch it. Okay, try it again. Touch it again. Okay, thank you. Can we have some light? Thank you very much. Equal charges repel each other. I've shown that, the demonstration with the balloons. Here we have an instrument which is called the Van de Graaff. It's named after Professor Van de Graaff, who invented it. He was an MIT professor. And this instrument, which I will not discuss in any detail now, but you will understand it later on in the course. I'll tell you all about it later. Think of this instrument as a super amber rod. And although we don't know yet what voltage is, I mentioned already the 20,000 volts between Simon and me, in this instrument you have to think in terms of several 100,000 volts. So this instrument is not without danger. But that of course makes it more exciting to work with it. So it's a super amber rod. And what I will do first now is to put some confetti on top. And when we turn on the Van de Graaff, the confetti may at first go to the charge dome, it is already on top of it, and when it picks up some of the charge, it will then spread out because it will repel. And so let's get some light on there, which will make it a little bit better to see. Let me put some of this on top. It's just regular confetti, pieces of paper. All right, now all I have to remember is how to start the most of the action has already occurred. I will put a little bit more on. If you see sparks, don't worry yet. Put some more on. Oh, boy, nothing left for the second class. Make it perhaps a little darker. Ah, that's too dark. Okay, we'll try it once more, give it a zap. So look at the confetti on top. And I think it's quite convincing. Some of the confetti will stay there. Well, that's for reasons that it's not a good conductor. And so it gets first sucked in, and if it doesn't get charge of the Van de Graaff, then it will not spread out.